Here's a question where we are asked to find the thrust of the rocket, the force produced by the engines at the launch. Now, in order to do this problem, we've got to be able to draw what we call a free body diagram, a diagram which shows the forces acting on the rocket. And we will limit ourselves just to forces acting vertically on this rocket. Now, don't draw a picture of the rocket. Content yourself just to draw a small dot which represents the rocket. Now, what are the forces vertically acting on the rocket? Well, obviously, it's got to be the weight of the rocket, which has always been acting downwards. And the weight of the rocket is given by the mass of the rocket multiplied by the gravitational field strength at that particular point in the planet. Now, we presume it's on the surface of the Earth, and therefore we're going to have G equal to 9.8 newtons per kilogram. So we now have got the weight arrow in. Remember, those arrows are really vectors. The length of the vector gives you an idea of the size of the force. And in this picture, the weight is acting downwards. What's the other force acting vertically? Well, it must come from the thrust of the rocket, or the force produced by the engines at the launch. And that's what we call the thrust. So we can put that there like that. Now, because the rocket is accelerating upwards, then that must mean its acceleration has got to be upwards. The thrust is bigger than the weight. And we can actually check that by moving the vectors about so that the tail of the thrust vector is in line with the nose of the weight vector. And you can see that the thrust vector is larger than the weight vector. And the difference between the two of them, thrust and weight, gives rise to what we call the unbalanced force. So the unbalanced force between the two of them is really the thrust take away the weight. Then we'll put those force vectors back to their top positions again and move this one over here. And we're now ready to set up this little template to work out the answer to the problem. So we've got to find the thrust of the rocket. Now, the first thing is that we can find the weight of the rocket. That's quite easy to do. So the weight, W, is equal to the mass times the gravitational field strength. So the mass is 20,000 kilograms. 20,000 kilograms multiplied by 9.8 newtons per kilogram. So we'll do that in your calculator and you should get an answer of 196,000 newtons. Now we also can work out the unbalanced force, because we all know that the unbalanced force is always equal to the mass of the object which is accelerating multiplied by its acceleration. So the mass of the object is 20,000 kilograms, and we have got acceleration to be 15 meters per second every second upwards. So multiplying those two numbers together, and we get the unbalanced force to be 300,000 newtons. Now this is where our diagram really comes into play, because the thrust of the rocket must be bigger than the weight of the rocket by the unbalanced force. So the thrust of the rocket must be equal to the weight of the rocket, which we've just calculated to be 196,000 newtons. And it must be bigger than the weight by the unbalanced force. So we've got to add on the unbalanced force, 300,000 newtons. So now we have the value of the size of the thrust of the rocket, 196,000 plus 300,000, and that's going to give us a value of 496,000 newtons. So the thrust of that rocket is 496,000 newtons. It is exactly 300,000 newtons bigger than the weight, and that's what causes the acceleration. Now let's take a look at the situation where we're in a different heavenly body, we'll say the moon, and we have got the actual object accelerating downwards. So here we have the Lunar module. That was a spacecraft which took the men to the moon's surface between 1969 and 1972. The Lunar module's got a mass of 15,000 kilograms, and in this particular case it's accelerating downwards towards the surface with an acceleration of 1 meters per second every second. And once again, you're asked to find the thrust force of the engine. Well, once again, we put in a representation of the lunar module. A small dot stands for the lunar module. And our next move is to put in the weight of the lunar module. So we put in the weight like that. Weight equals mg. And we can go ahead and calculate that in a minute. But be careful, because we're on the moon. And we've got to remember that the value of g for the moon, the gravitational field strength for the moon, is 1.67 newtons per kilogram on or near the moon's surface. Now, what's going to be our next force? Well, obviously the rocket is using its motors to push it up the way, the thrust up the way. So we've got to represent the force called the thrust by an upwards vector, an arrow pointing upwards. And you can see in this particular example, because the lunar module is accelerating downwards, the weight must be bigger than the thrust. The thrust is not big enough to support the weight, if you can imagine that. And we can show you once again by bringing the thrust vector down and adding the tail to the nose, and you can see the weight vector is going to be bigger. We actually could add the nose to the tail as well, and we can see that the unbalanced force, that's the difference between the weight and the thrust, will be that one there acting downwards. So let's put the vectors back to their position again. The thrust is up here like that. Let's do the calculations then. First of all, the unbalanced force, we can work that out, because the unbalanced force, we know, is always equal to the mass times the acceleration. A key point: unbalanced force, mass times acceleration. And the mass of the lunar module is 15,000 kilograms. So we can put that in. And we know the acceleration of the lunar module is 1 meter per second every second downwards. So we can put in 1 meters per second to minus 2. And remember, our answer, 15,000 newtons, will be acting down the way. The unbalanced force is acting downwards, which means the weight must exceed the thrust by 15,000 newtons. What is the weight of the lunar module? Well, the weight on the planet is equal to the mass times the gravitational field strength, which is equal to 15,000 kilograms multiplied by, on the moon's surface, 1.67 newtons per kilogram. And if we work that out, we get the following answer. We get that the weight is 25,050 newtons. So the thrust must be less than the weight by a value of 15,000 newtons. The thrust must be less than the weight, so the thrust must equal to the weight, which is 25,050 newtons. Take away the unbalanced force, which is 15,000 newtons. So we do that little calculation, and we're left with 10,050 newtons. So that must be the thrust. So you can actually see or get a feel for the calculation, because we know the thrust is less than the weight, and it's less than the weight by the unbalanced force of 15,000 newtons. So these are two examples for you to go and study, and the key thing about these examples is to set out the template involving the forces, the force vectors. Use the weight and the thrust, and beside it you can put down the unbalanced force, because it's unbalanced force which is acting downwards in this particular case.
Physics is wonderful. Physics is cool.